Good afternoon, everyone. I'm Stephen Floyd with Producer Ag Insurance, and we have Brian Bledsoe with us today, our weather consultant, to bring us some information on the current forecast and what we can expect here through the next 30 days and moving into fall. Just want to go ahead and thank everyone for joining us here at the 1 o'clock hour. And there's a lot going on out there. So, Brian, bring us up to date on what's happening out there and what we can expect over the next 30 days or so.
All right, Steve. Thanks for having me. Good to be here today. And we're just going to kind of walk you through a lot of the seasonal forecast model information that's come in this month. A lot of this stuff came out around the 5th and the 7th. You might have seen some of the stuff that I put out earlier. So this is just kind of a recap before we move forward. But before we can kind of delve into that, I just want to show us where we are as far as the long-term drought index is concerned. And I know that the drought monitor gets a lot of run, and I see that stuff on social media and online. And I'm not trying to throw the drought monitor folks at University of Nebraska at Lincoln under the bus or anything, but I think these different drought indices measure things a little bit better in terms of who's seen what. In terms of long-term drought stress, all right, we still have significant problems in this area that I'm highlighting. And I don't even think this really does it justice for what we've seen, because up here in northeast New Mexico, I think it's drier than what we're seeing. I think parts of southwest Kansas are drier than what we've seen. So again, this is over the long haul, and you can see areas the farther east you go has been better. And if you're wondering what this little green blob is right in here, that represents Scott City, Kansas. That represents Dighton. That one area, you want to talk about going from great to not great over a short distance. That's exactly what you're looking at there. Short-term drought index explains it a little bit better, in my opinion, because this corridor has been quite wet over the past, say, 30 days or so. But if you come southwestward, especially out of northeast Kansas, you go to central and southern Kansas and all the way back here into eastern New Mexico, these are the areas that are really struggling. We had a good rain in the Texas Panhandle last night. I think Dumas, Texas picked up over 2 inches. That's the biggest one rain that they've had, I would say, all the way into probably fall of last year. It's been perilously dry down here. You might say, well, why are we worried about that? Well, because drought rarely ever comes at us from the north. It almost always comes from the south. We need to fix this in a big way over the next 8 to 10 months. And I'll go into more detail why. But if we don't fix this, then that drought has a foothold and it can readily expand, even when we have short spells where we don't get any moisture. If that drought isn't completely erased or greatly mitigated in that next 8 to 10 months, we're going to be in not so good a spot, I think, as we head through 27. So I want to kind of put a pin in that for now, because I'm going to tell you why that's so important here in just a bit. But past 30 days, this is the anomalies that have occurred. Can you see the ridge? I mean, it's really easy to see who's been underneath that ridge. That ridge has been camped down here. The storms have been riding that ridge over the top just like that. We talked quite a bit about that last time we spoke. All right, but in the summertime, especially in later in July and August, when that ridge sets up over the southern plains, that's historically where it's supposed to be for that time of year. So it reinforces itself and becomes incredibly hard to get out of the way. Plus, when you add to the combination that there's no soil moisture in a lot of these places down there, the drought just rapidly enters that positive feedback mechanism, and the pattern becomes incredibly hard to break down. That's not to say that everybody has been left high and dry. Like I said, west central Kansas has done pretty well. There are pockets over northeast Kansas that have done okay, but most of these spots farther south haven't done very well at all. That's Dodge City, 36% of average over the past 30 days or so. And when you factor in the heat, it's been awful. And then these communities over southeast Kansas, between 16 and 17%. And it's even worse down here across Texas, which haven't seen really anything. So that's where we've been. The current state of the oceans look like this. Real strong El Nino going on, likely going to be a record-setting event. The Atlantic has warmed up quite a bit from what we talked about earlier this year. We've also seen this part of the North Pacific warm up quite a bit from where we've been over the past several weeks and even the past few months, is this area was a little bit cooler than average. And I'll show you what's gone on with the change over the past couple of weeks. These are the sea surface temperature anomaly changes. So we've cooled this area off quite a bit while we've been warming this area up. All right. And I think that's important because I don't want to see any cooler than average water up here next to the west coast of North America. I know we've been dealing with some of that. I don't think that's necessarily going to completely go away, but I would much rather have this change take place over the past couple of weeks versus something else. We've also continued to warm up this area of the equatorial Pacific, with the ongoing El Nino situation that is occurring. This map, I think, tells an even bigger story. When you look at the sea surface temperature anomalies, and you compare them to what the global mean sea surface temperature anomaly is, some of these things stand out a little bit more. Case in point, this cool area right here, that stands out a little bit more. So does the warmth over the top. The El Nino is very prominent, obviously. Why is this important? Well, because I want to see temperature differences in the sea surface temperature anomalies out here in the Pacific, because if we see that, you see this right here, that difference fuels the subtropical jet stream that's going to get going this fall and winter. If we don't have these temperature contrasts, then it slows down the jet stream and it slows down the pattern. The storms are less frequent, so on and so forth. So this is a good thing to see these temperature differences here, especially as we go into the seasonal change and as we wrap up this year. And I think that certainly bears watching going forward. If we look at what's going on in a little more detail, this over here is Indonesia on the upper left. This is South America over here on the right. And this little rectangle, this short rectangle up here at the top, that's at the top of the ocean. This is what's going on beneath the ocean. These are sea surface temperature anomalies. And this area in particular, those anomalies are running about 15 to 16 degrees Fahrenheit above average. I've never seen a signature like this since I've been covering weather in my lifetime. Have there been signatures like this in the past? I think you have to go all the way back into the late 1800s to see something like this, which, obviously we didn't have good ways of measuring things, but this is likely our record-setting event. Now, don't ignore what's going on over here on the left, because all we've done for the past 2 years is pool warm water over here in the Western Pacific. The past several months, westerly wind bursts doing this have shoved all that warm water farther east. So what that does is it leaves a void of warm water over here in the Western Pacific, and that paves the way for a likely handoff from El Nino to La Nina later in 2027. I've been talking about this in our past sessions, and I don't see any reason to, change what my thinking is because of this signature. Now, before we get that, all of this warm water beneath the surface still has to come to the surface in one way, shape, or form. Not to the magnitude it is beneath the surface, but what I'm saying is that this El Nino has plenty of fuel in the tank, all right? And it's going to continue to be very strong. And the latest computer model information, at least from the Euro, show this thing peaking out November and December, and then we come off of that peak. But keep in mind, that's February, all right? This is out to February. As we're coming off that peak, just the mean of all of those members there still puts our sea surface temperature anomaly plume here above 2.5 degrees Celsius. That's still in really strong El Nino territory. So this El Nino isn't just going to rapidly collapse, at least early in 2017, but I do think that trajectory is going to continue as we enter spring. And so does the Bureau of Meteorology out of Australia. They're also peaking this out in November, December. We come off of that peak a little bit, but even then, they're still in February. It's right around 3 degrees Celsius above average. So the message here is that at least through the first couple of months of 27, this El Nino event is still going to be very strong. And the overall pattern that is associated with whatever this El Nino has to deliver is going to continue into at least the first third of 27, but probably even closer to the first half. All right. What happens after that? This is a metric that measures how well the ocean and the atmosphere are talking. This is called the multivariate ENSO index. So we can go back to 1979. I want you to look at what happened in 1982 and 83. I know this was a long time ago, but it bears looking at to see kind of what the trend is likely to be. This metric maxed out at 2.9. That's an all-time record since we've been measuring this in 1979. It maxed out in April, May of 1983. But look what happened after that. Do you see that? We went right from strong El Nino to weak La Nina. That's what those negative blue numbers represent by August, September. Very rapid collapse right there. And once that weak La Nina was established, it was a multi-year event. We didn't see any type of an El Nino signature come back until 86. So what this is telling me is that from a historical standpoint, whenever we have a real strong El Nino, a lot of times when it collapses, the atmosphere overcorrects and we go right back into a La Nina episode. It can be a strong episode too, and a multi-year episode. And you'll see some of that here as I kind of unveil some of the breadcrumbs. 1996 and 97. All right, look, and even in the 98, 99. Look what happened here. 96, we started out La Nina. We finished it. Oh, look what happened. Started out La Nina here. Rapidly went to a strong El Nino. We maxed it out March, April of 98. And after that, we were already in La Nina mode by June, July. Do you see how rapidly it collapsed? That was actually the most rapid collapse of a strong El Nino and transition into a strong La Nina that we've seen. And it was a multi-year event. We continued that strong La Nina episode even into 99. And even, look at this, right through 2001. We didn't see that El Nino signature come back until 02. So that was actually a 3-year type of event where we were dealing with La Nina conditions there. All right. What about the two teens and 20s? Well, 2015 and 2016. Strong El Nino. We were still in El Nino April, May of 16, and then we went to La Nina to finish that year. And look at what we did. We continued it even into 2018. Not necessarily in a strong way, but you see what happens here. 23 and 24. El Nino developed later in 23. Wasn't crazy strong by this metric, but we went right back to La Nina, June, July of 24, and continued that until March, April of 26. I don't have any reason to argue with how history goes here. And I can double down on this by looking at the computer model information that is looking the exact same thing. This was the July run. I'll get another update here in September. They didn't have an August version. But what you need to know on this map is that the blue bars or the red bars represent El Nino probabilities. So you can see over here, we start July, August, September of 26. We keep those red bars, those extreme El Nino probabilities, very high. And then we deal with a rapid collapse of that. And we have a rapid rise of La Nina probabilities here. The crossover is right there, May, June, July, August of 27. Could this collapse happen sooner? I suppose it could, but historically speaking, we still, with a strong El Nino like this, we will probably still keep that El Nino signal going between the ocean and the atmosphere, probably through April, May, June timeframe before we really collapse it and those La Nina probabilities go up. So what we will, just like this past, earlier this year, all right, where we saw the handoff from La Nina to strong El Nino, this next year in 27, we will likely see the exact opposite. Strong El Nino goes to possibly a strong La Nina. How rapidly this event intensifies over here is still in question, but for this model to be putting out probabilities by July, August, September above 60% that we're going to be in La Nina, that's a significant signal that bears watching. The question I have, and it's an important one, how big of a window or small of a window is it going to be in here where our pattern is kind of neutral? Because during a neutral pattern where we're not in El Nino or La Nina, that neutrality, we do okay in terms of moisture. If you remember what happened last summer, we did okay because for the most part, we were in neutral territory. We weren't in El Nino, we weren't in La Nina, but I think this window is going to be a short one. So that puts a lot of pressure a lot of pressure on the weather patterns that are going to take place, as I said, over the next 8 to 10 months to see how much water we can shove in the soil, not only in our immediate area, but also farther south in that real drought-stricken area across the panhandles, northeast New Mexico, parts of Kansas, Oklahoma. The more we can mitigate that dry area farther south, which is a good thing because El Nino a lot of times favors that southern storm track, the better off we're going to be. Because I'm a little nervous about this La Nina episode over here when we come out of this into 27 and even into 28. Because like I said, once that La Nina is here, it's probably going to be a multi-year event and it might actually have some strength to it. And I don't like either El Nino or La Nina, all right, because they breed extremes. We've seen that with this El Nino going on right now. But in many cases, the farther west you go, when a La Nina is present, that is usually a harbinger for more drought issues than what we would like. Winter patterns. Over here is La Nina, all right? High pressure out here, and this is an important difference. Jet stream goes up into Canada, comes right down like this. A lot of times that will be able to bring us down a lot colder air during the winter. There's no subtropical jet stream farther south, so you are drier farther south, okay? But with an El Nino, especially a strong one, we have low pressure out here. That floods the countries, and I say countries because I'm saying Canada and the United States, with warm Pacific air. Meanwhile, we have a ripping subtropical jet going across the southern tier that keeps the southern part of the country wetter. Now, I know up here, this is just a general idea of what these patterns do, all right? But up here, I know it just says warmer, but I am worried about snowpack issues in the northern and central Rockies and across the northern plains. Kansas kind of leans toward the southern end of that boundary where it's warmer, drier to the north and wetter to the south. But for the most part, Kansas is still kind of right there in the middle. I still think the farther south you go, the better opportunities you have to see meaningful moisture and more frequent moisture. So we'll put the models to the test here. September to February, these are the temperature anomalies from the European model. All right, we're still dealing with some warmth here, maybe some late season warmth over here as the ridge sets up a little farther east. October, we cool things off. I was talking with Steve before we started this, and I said I've already started to see some of these models in longer range painting stronger cold fronts and also some snow up here across the northern Rockies, even in the middle part of September. So I think once this ridge goes away, it's really going to go away. And we'll see a completely different pattern evolve, which is very much on brand for a strong El Nino, where we flip back and forth between those extremes. November, you can see where the storm track is down here. The cooler than average that you see here in Texas and the Gulf Coast is not from strong cold fronts and Canadian cold air pouring down from the north. It is not that at all. It's because we have a lot more storminess and cloud cover down here, reducing the amount of sunlight that we're seeing. And you'll see that continue here. This is December, just a blowtorch across the north because all that Pacific air coming in here. Meanwhile, we've got the subtropical jet doing this, keeping things cooler south. January, I've wondered about this signal for a while. What would kit this area here across eastern Colorado, the western half of Kansas, down into the panhandles? What would make this so much cooler than average during January? And I think it would be one or two big snowstorms. That's the only thing I can figure out here because there's no cold air coming south with this. This to me indicates an active storm track that would put snow on the ground and keep it colder than average because you see that for January, it's still there in February. I think that's what the model is telling us. Is it reality? Who knows? I mean, we're talking a long ways out, but history would suggest that with that strong jet stream coming across like this, that we would have some active weather on the wintry side of things to worry about. And to be honest with you, and I don't care if you've got cattle or not, because I've got cattle on our ranch or whatever, we need a strong winter. We need a big winter down here farther south to really fix things as we go into 2027, in my opinion. Precipitation-wise, same model, same time frame. September continues to look wetter than average here through the west and across the plains. October, This is when we start to see the signature set up a little bit more with that strong subtropical jet, but even farther north, it doesn't screen dry. All right. November, I'm concerned about this dryness here. Not for Kansas, but for these mountain areas. This would be the second winter that these mountain areas had missed out on. If that's the case, things would go from bad to worse here in a major way. And especially if you have interests up here in Northeast Colorado along the Platte River and even up into Western Nebraska, along the Platte Valley from an irrigation standpoint, because we didn't have any of that this year to speak of. And that really caused some real problems. So if we don't have a winter here in the central and northern Rockies, especially here, in Colorado, then we have problems, at least in the mountain areas, leading to bad irrigation flow downstream. December, do you still see the dryness here? Meanwhile, you have slight wet signal going on here in December. Look how wet California is. Look how wet things are here. But I don't like this dry signal here for the reasons that I'd mentioned. January, remember I was showing you that cool air, cooler than average. You see how it's a little wetter than average here? Again, I think that's because it's putting snow on the ground, keeping it colder, because it's there in February too. See it even expands a little bit here. And I think that lends itself to storms coming in like this, low pressure setting up here, and we keep it stormy here in the middle part of the country. The one question I have, and it's not going to be answered today, it's going to be answered in the next couple of months, is how far north or south does this storm track set up? Because if it sets up down here, we're too far north up here in Kansas for it. All right. It benefits areas south. If it sets up here, we're going to do a lot better. That's going to be huge. Historically, the stronger the El Nino signal, the farther south that storm track ends up. And I know we're kind of in uncharted territory right now because of the strength of this El Nino, but watch where that storm track sets up, because that's going to be a tell as to what we're going to see going through fall and winter. The NMME model, September to April, these are temperature anomalies. That's September, October, November. Again, this white is due to the storm track. December, again, this is not due to cold air pouring down like this. This is due to wet weather down here. So watch that expand. January, same thing as what the Euro was showing, right? February, March, and April. When was the last time we had a colder than average January, February, March, April? I can't remember the last time of any consequence. Can it happen in an El Nino? It can, especially if the storm track sets up in the right spot, because it'll put down quite a bit of snow and moisture in a period of time. So let's see if the model's doing that. This is September. Again, keeps us wetter than average for the most part. Average to wetter than average. October. November. See that storm track sets up a little farther south. Okay, but still doing okay here. Main dryness is up here. December. January. Still has wetter than average. Again, I think that cool signal is because of the amount of snow that we're seeing here and frequent storms coming in from California and through the Southwest, because it's there in February too. In March, it's there. And April, it's there. When was the last time we had a wetter than average January, February, March, and April? Again, I can't remember off the top of my head. So it's one of those things where that's great. We're looking at this digitally, all right, but it has to do it. And I think that its ability to do something like this is very much predicated on how far north or south that band sets up. But the fact that the NMME and the European model are kind of on the same page here means that we need to be paying attention to that. The Copernicus 3 model, September to January, these are temperatures. October, November, doing the same thing as the other models. December, and January. Same deal here. All right. But the core of the cool signal is a little farther south. All right. Precip wise, again, September is very consistent with the other models, keeping things for the most part wetter than average, especially farther west. October, wetter than average. Watch this dry signal build up here, though. November, that's where your core is here. Doesn't mean we're not going to strike that we're going to strike out, because we still got some green here. But look at the dry signal up here, expand. That's because this is void of the storm track. It's all down here to the south. December, that dry signal, especially that darker brown, really expands. And January, see that little bubble there? That's obviously due to the storm track coming in farther south, and we're drier farther north. So I think certainly there will be a huge difference here from northwest to southeast in the plains as far as who sees what. Again, an extreme pattern, haves and have-nots. Climate Prediction Center drought outlook. This goes through November 30th, and the Climate Prediction Center thinks there's a lot of drought repair that's going to go on in this area here. All right, a lot of drought repair. Should it happen? Historically, it should, because of the El Nino signature. Will it happen? That's yet to be determined. I think we have to be a little bit guarded about that until we actually see the pattern show up and do what it's supposed to do. So I would continue to play my cards a little close to my vest until we see that pattern actually set up. But this was a pretty big move for the Climate Prediction Center to show that, and I'll show you why. When we look at its precipitation and temperature anomaly forecast, September to March, all right, September, October, November, it's consistent with the other models in keeping this corridor wetter than average and really no dry signal in the middle part of the country. Temperature-wise, warmest north. October, November, December, wetter than average all the way through here, especially from southwest Kansas, southeast Colorado, down here into New Mexico and Texas. Temperature-wise, the white essentially would mean average to cooler than average. We are blowtorching over the top. November, December, January, still the same signal. Wet south, drier north, really warmer than average north, generally average to cooler than average south. December, January, February, look how wet this corridor is here and here. But there's no cold air coming down. Doesn't mean we won't see snow, all right? But it means that we're not going to have that Arctic air reinforcing it. What we would have to deal with in terms of cool temperatures is if we get snow on the ground and it just doesn't go away, all right? But even December, January, February, a lot warmer than average north. That does include central and eastern Kansas, obviously. January, February, March, we continue with that same kind of signal, all right? Same signal temperature-wise, too. Very classical signaling for a strong El Nino, basically what you would expect. The latest IRI, this model is an interesting one because it takes a lot of signal to move the needle one way or another. So when we look at the September, October, November precipitation outlook, when you're seeing dark greens in here, that means it's at about a 50 to 60% probability of being wetter than average. That's a big signal for this model. And when you see the blues, that's an even bigger signal. Okay, so it's got September, October, November looking average to wetter than average, certainly for most of Kansas. Certainly the bigger wet signals farther south. But when we go October, November, December, we kind of continue that thinking. Wetter here, still wetter than average north, just not in the blue. November, December, January, model I think is putting it here, but we're still doing okay. Look at your dryness expanding up here. December, January, February, that dryness starts to leak a little farther south. You can see that here. All right, I'm just kind of highlighting that all the way up here, out of Alaska and Canada. That's because, again, the flow is doing this with your main storm track farther south. Temperature-wise, this isn't going to tell you a ton other than just this Pacific flow is going to keep us milder than average. October, November, December. November, December, January. Notice the little kind of cool signal that sets up down here due to the active storm track. Okay. And then in November, December, January, again, we're sitting there. So generally the conclusion of this is the strong record-setting El Nino is going to influence our forecast at least into early 27 and probably even a little bit beyond that. All right. Probably through spring before that collapse. Every El Nino is different. There's different nuances that sometimes can buck that historical trend. All right. We've got to stay current with those nuances and those developing trends as they happen. I say this all the time. This is not something we look at today and not check in and again 3, 4, 5, 6 months from now, because I guarantee you the details with this forecast will change as we go forward. Historical trends and modeling suggest major drought relief is coming from some, while others will likely have drought development. I showed you those highlighted areas. And probably the biggest signal that when this El Nino ends, La Nina is going to return later in 27. I feel pretty confident in that. I think it could be a strong event as well, and I think it could be a multi-year event, which is going to have implications too. The thing that really stinks about this is that if we don't capitalize on this El Nino one way or another, all right, our window of opportunity for those neutral conditions is a short one before we get shoved into the other phase. So I want to reiterate, the next 8 to 10 months is very important. I know that just seems like common sense, but I think it's even more important now than at other times because there's so much at stake and we have so much drought to fix in our immediate area and especially just to our south. So with that in mind, if you guys have questions, please feel free to fire away.
Yeah, thanks, Brian. Just want to remind everyone that the chat feature and the question and answer feature are live, so you can type some questions in there and we can ask Brian as we go here. Brian, just as we're kind of moving through this, can you give everybody a little bit of a refresher on now through the next couple of weeks, that first half of September, as we're dealing with harvest and guys thinking about making some decisions on purchasing inputs for 27 wheat and whatnot?
Well, I mean, I think it's going to depend if we can actually get some water. There's some areas in western Kansas, that have done very well here lately with this pattern. That's especially around Syracuse, northward up toward Sharon Springs, Scott City, Dighton. That area there has done very well. So I am optimistic as we go into September that with this ridge breaking down, that moisture will become a bit more widespread. All right. There's some things in the modeling that show that. But I'll tell you, Steve, and a lot of other folks, I'll believe it when I see it. I'll put it that way. I want to see evidence of this ridge completely breaking down, model run after model run after model run, and not just the ridge breaking down, but better opportunities for moisture. So as I always say, I do this stuff every day. I look at this stuff and I walk people through these next 2 weeks and beyond every single day. And I like to build that narrative to see if the modeling is remaining consistent going forward, because you're going to see, at first chance of a significant storm coming in, you're going to see a lot of stuff shotgunned all over the internet and social media. I think we have to be very measured about that type of information with our expectations because of what has happened with some of the dryness. That's especially true in the southwest part of the state. There are other parts of the state that are doing better than others, but as a whole, I think we need to be very cautious and watch this stuff very closely over the next couple of weeks before we really make any wholesale decision. If you've got moisture at your place, great. Go ahead and do what you need to do. But if you don't, let's pump the brakes and see how this is going to evolve.
Yeah. Yeah, as far as like temperature moving into the first part of September, I mean, is this heat ridge going to hold on for an extended period of time, or what does the evidence look like that you've been looking at there?
I don't see it going away immediately, all right, because it takes quite a bit to break that signal. I see probably more evidence of that signal breaking down after the first week of September and as we push more toward the middle part of the month, because something of this magnitude, as well as I do, just doesn't immediately vanish or go away.
Yeah, for sure. And maybe as we look forward a little bit, looks like maybe a little bit cooler than average, wetter than average, moving through the fall and winter time, even into the spring, as that pertains to pasture land, the guys with cattle out there and whatnot. I mean, is that just slightly above average, you think? Or, I mean, is it looking like significant rainfall? I know it's hard to tell.
Well, the signal's strong. All right. The
Yeah.
signal right now is strong, but it's in the modeling. And you probably, you're probably noting a little bit of pessimism in my voice. Okay. And I think because of that, I mean, you look at what our ranch has had in eastern Colorado, and there are pockets on our ranch that have had less than 4 inches of total liquid so far this year. You know, we have pastures that in places look like the moon. All right. So there's a little bit of that pessimism in there because there are other areas close by that have done very well. So the pattern as a whole can look really good. Inevitably, there's always going to be have-nots in that pattern because of where we are right now. And the pattern has not been kind to Southwest Kansas recently. It's been much more favorable Northeast Kansas. I drove from Kansas City to Wichita a couple of weeks ago, and it was green as could be until I got closer to Wichita. And then so we're seeing these big contrasts over fairly short distances. So what I want to see first, before I really sign off on a lot of the stuff that we've seen digitally today, I want to see really solid evidence of the pattern change and some reinforcements that are going to tell me that that pattern change is going to stay there. So like I said, it's going to be critical over the next couple of months where that storm track sets up, because if it sets up too far south and we see it do that, then we're probably going to get shorted. All right. Again, it goes from the reality of the situation to just what looks good digitally within the modeling. All right. So it's going to bear a lot of watching. And I know that that's not the answer that everybody wants. They want to say, oh, you feel real confident about this. I don't feel real confident about it yet. I know what the models look like. I know what history suggests should happen. But I think the biggest tell with this, and this is usually the case, is that the farther south you go, the better opportunities historically you're going to have of seeing more frequent moisture and moisture that'll actually do some good. There's evidence that shows the farther north you go, not so much. All right. So I think right now, that's the big takeaway with this, depending on where you live in the state.
Yeah, no, thank you for that, Brian. So I don't see any additional questions coming in. Again, thanks everyone for your attending our virtual weather meeting. Look forward to seeing you next time, Brian, and hopefully this cooler, wetter weather gets here sooner rather than later.
You and everybody else, Steve. Absolutely. Thank you for having me today.
Yeah, thank you, Brian. Talk to you
bet.
next time.